Invision Hope Healthy Living, and today we will be testing the pH of these household items. Hi Hope, how are you today?
Hi, good. Hi guys, so today Pearl is going to test the pH of these food items and liquid that you can find in any household really. And it's very important for you to start learning the basics of science, right? Like, one important thing is to always label your containers, which is what you did, because if you don't label your containers, you're going to see that this liquid is really clear liquid. This is water, but hey, it can be confused to vinegar, right? So it's important. So what else do we need? Now that we know our containers are labeled, we have ingredients there, we're going to tell you what those ingredients are as we move on. I will be assisting you. So can you tell us more about the pH?
So you might be wondering what pH stands for. pH stands for the potential of hydrogen.
Yes, and to put it simply,
let's just say it's how sour or how bland or non-acidic something is, or basic. Yes,
so if you take a pH scale, it's from 0 to 14. 7 is the middle, right? So that would be like your neutral zone. And if something is like around 8 or 9, you say it's basic. We also say alkaline, but that's a fancy word. But if you are going down below 6, 5, 4, those items will be very acidic, like your lime. Okay, so let's get started. We need to wear our safety glasses always. And guys, this is a very cool science experiment, but you only do it with parents.
And guys, make sure you have a pH testing kit.
Yes.
Like we do.
Yes, and this is actually a leftover testing kit from my 13 years old science experiment, right? And he took first place at the science fair, testing the pH of rainwater versus tap water in growing chives. Okay, so we are going to wear our gloves. It's always good to have as many protective gear, just so that in case there's a spill, you are protected. So we have our apron, gloves, safety glasses, and we are ready to go. I'll be assisting you, so you tell me what we are doing. So
first, let's start out with our vinegar.
Yes, and maybe I can bring this closer so you can see. I hope you can see right there. And you're going to see on this side, this is what we're going to use to test our pH. And if we're going up, you see the purple, and it gets even more intense. This is where you're going to alkaline level, and if you are going down, you're going to get something that is more acidic, and this is a little bit like your neutral zone. So this is what we're going to be doing. Okay,
so for our liquid, it's called phenol red.
Yes.
We're going to use only 4 drops.
Yes. Okay, so I'm going to hold it like this. So we can we're going to start with lime.
We're gonna start with vinegar.
Vinegar, okay, that's good. If Pearl wants to start with vinegar, so we're going to pour.
We have to put the liquid first.
Oh, okay, great. She knows better than Mom, so that's good. How many drops are you putting?
4.
Good. You have to speak loud, remember that, so people at home can listen, can hear you. So
and now we're going to put some vinegar.
Yes. There. And there's actually a line not to go above it, so we're going there. So this is good. And then we have a little cap, so you're going to put it there, and you're going to mix it up a little bit. It takes about, few minutes. I would say 3 to 5 minutes, and then we're going to read it. Good. So it's well mixed. Let's say 1 minute. So we're going to leave it, and when we come back, we are going to read the result.
Okay guys, now I'm going to show you the result. Here we have the vinegar in here, and it turned a very, very light yellow. So I'd say it's about 6.8. And there's definitely a difference that the reagents made it like a reaction with the vinegar, because it definitely didn't start out yellow. So yeah, let's test the next one. Okay, next we're going to use some dish soap. Okay guys, now it's time to test our next liquid. So we have to rinse out our container.
Yes.
And just dump it in here.
And then I'm going to pour a little bit of water to rinse it out, so we don't have any vinegar in there. And now we're going to the next ingredient, which is
dish soap.
Okay.
So first we have to.
I'm going to hold it for you.
Drop.
You have to speak a little bit loud.
1, 2, 3, and 4.
Yes, 4 drops. And then we're going to pour the dish soap. There you go. It doesn't have to be full, so you have to make sure you have some room, because we're going to flip it, right? Okay, so we do this to mix it with the reagent, and then we wait about 5 minutes to read the results. So
maybe a little extra for this one, because it is pink, so it might be hard for the reagent to change the color.
Okay, so we'll see. So when we come back, we're going to read the results.
Okay guys, so we let the dish soap sit a bit, and it looks like it turned to be about this color. So we think it's about 8.0 or 7.6. It's kind of in the middle of these two. And you can definitely see it did change a little bit color-wise from the normal dish soap. Okay guys, next we're going to test milk. Okay guys, now let's rinse out our container.
Yes, great. And I'm going to pour some water just to make sure that we rinse out everything, right? Good.
Great. Now we're going to be testing the pH of milk.
Yes. And when I drink milk, I don't really feel it, acidic, or it just tastes bland.
Yeah.
So I don't know. Would that be?
I think it will be in the middle.
Okay. Well, good. Let's test it.
Okay. Just like before.
Yes.
Drop.
1,
2, 3, 4.
So just 4 drops. Good. And then I'm going to pour the milk. And we can see that our reagent is red, right? And let's see what will happen when we put the milk, which is really white, cream white. And again, don't forget this step. You have to cover, put the lid. The lid comes with the pH kit, and then flip it, right? So this just helps to mix it. And we leave it for about 5 minutes, and when we come back, we are reading the results. Don't go away.
See you soon.
Good. Hold it. Good.
so we let it sit for a little while, and here it's really hard to see, but the milk kind of turned just a little with a tint of purple. So we're going to think it's about 7.6. It definitely changed a little bit because we can see the difference of these two. Okay guys, next we will be testing water.
Okay, and what do you think happened if you let milk sit for a long time? You know, like age?
It will probably become more sour, and therefore if it's sour, then it would be somewhere down here.
Yes, because it will become more acidic, right? Okay, so what are we testing next?
Water.
Okay, don't go away.
Okay guys, next we will be testing water. We already went ahead and rinsed out our container.
Yes.
Okay.
I'm going to put one more drops.
So I'm going to put in 4 drops. 1, 2, 3, 4.
Great. And I can help you close the lid here.
Okay, next we're just gonna take this tap water.
Yes. Do you want me to help holding this? It doesn't have to be full.
Wow.
Yes. Good.
That turned very good. And this, I think I already see what color it is. I think it would be around 8.0 because it doesn't look very, very pink.
Okay.
But it doesn't look too light.
Okay. And this is water. So when we come back, after a few minutes, we're going to read it.
Okay guys, so we let the water sit a bit, and here we think it's about 8.0. Now, depends on where you live. If you live in a certain place, it might be lower or higher. The lowest will be 6.5, and the highest would be 8.5. So just above this number. Okay, but here we have this pink color, and we think it's about 8.0 to 8.4. And it changed a lot from the normal water. Now we are going to be testing the pH of this baking soda water.
Yes. And what do you think can be baking soda? I know when we use it to bake, we're supposed to add a little bit of milk or maybe something like buttermilk to help it rise. So I'm wondering if, you know, baking soda is more alkaline or acidic. I know the results, but I'm going to see if I will be able to find it.
I think it will be more acidic.
Okay, let's find it. She said acidic. I said baking soda will be a little bit more alkaline. But let's find it. Did you put 4 drops? Okay. Okay, we stir it so it is diffused. Yes, so we have even.
Whoa.
Good. Remember, she said it's going to be acidic, and I said it's going to be a little bit more alkaline. So let's see.
That's
when we come back.
really purple.
Yes. So we are going to find out when we come back who got it right.
We let this sit for a little while, and it turned really purple. So that means it's more basic, very basic. So we think it's about 8.0 to 8.4.
Yes, and you know, I was right. You know, Pearl thought it would be more acidic, and I say no. usually when I'm baking, I have to add acidic ingredient like yogurt, buttermilk, vinegar to help create that, you know, air bubble, which level the whatever baking food you're doing.
Okay guys, next we will be testing the salt water.
Yes. And you know, the experiment that we just did was really cool, right? Okay, so here we're putting 4 drops. And I always make sure that I read and maybe stir it too, because we want it to diffuse really well. And what do you think salt water would be? More on the acidic side or basic side?
I think this one would be more, maybe more basic?
Okay, so let's see. She says more basic and I would say the same, and we are going to test it.
Wow, that looks really pink, just like the baking soda.
Yes. And remember, salt, baking soda, these 2 ingredients are similar. These are salt.
Because I think they also have salt in baking soda.
Yes, definitely. It's a different kind of salt. So yes. So probably we'll be looking at the same, you know, the results. But you know, this is just our hypothesis. And when we come back, we're going to see if it is true or wrong, right?
Okay guys, so we let it sit for a bit and it ended up to be about 8.0 to 8.4. It changed a lot and it looks very similar to the results we got from the baking soda water, because there is some salt in baking soda.
Yes, baking soda and salt, these are both, you know, just a variety. It's a different
So
kind
Hope
of
and I
salt.
were both right.
Yes. Great. I think I love this experiment because I'm learning a lot, even though I'm behind the camera most of the time. Thank you, Pearl. Good. So what are we doing next?
Next, we will be doing lime juice.
Okay.
Okay guys, now this is our last liquid. We will be testing lime juice.
Great. And so I'm going to help you pour this. How many drops do we
4.
need? Good. 1, 2, 3, and 4.
Now to put in the lime juice.
Yes.
Whoa, that turned really yellow.
Okay.
We dumped a little
Yes.
out.
She put just a couple of drops more. So you want to make sure there's a line right here. I don't know if you can see the line. I'm going to come closer. So this is exactly where you want to stop. So Pearl just put 1 or 2 drops extra, but it's okay. We're able to put the lid there. And then what do we do next?
Shake it a bit.
Yes.
And I don't think we need to let this one wait that long because it's already really clear what color it is.
Well, this is giving us a good guess, right? So what do you think? Are we on the alkaline side
Definitely
or acidic
acidic.
side? Definitely acidic. Great. And a lot of time when you eat, you know, lemon or anything that, you know, like drink lemonade, what taste do you have?
Usually it's very sour,
Yes.
but not too sour because we add sugar.
Okay. So we're going to see what would happen next. Do you think it's going to turn purple or stay on the yellow side?
Definitely staying.
So I
Okay.
think we can see here that the results are that it is 6.2 and below.
Okay guys, now we're done and it's time to wrap it up. But first I'm going to leave you with 2 fun facts. Now we know that if something tastes bitter or bland, it will be more alkaline. But if something tastes more sour, then it will be more acidic.
Yes, great. And thank you. You know, it's been fun, and I hope that, you know, you guys at home can do this with your kids. But remember to have protective gear like gloves, safety glasses, and what else? Maybe an apron or a blouse. This is really giving you, you know, basic skill, basic science skills, right? And I know you love science. And another fun fact will be about rainwater versus tap water. What do you think?
Tap water would be more alkaline because it is it's just fresh water.
Yes,
but rainwater would be more acidic because of chemicals in the atmosphere that affect the water.
Yes, and also many counties and municipalities can actually regulate the amount of pH in the water. So that's why we see that it varies from region to region when we were reading to prepare this show. So guys, this was fun, and if we have more ideas, science ideas, we are going to bring it to you, but you can also give us some suggestion of what you like.
So if you like this video, make sure to like, subscribe, and comment down below some more fun activities that you want us to try. Also check out our Facebook page, Invision Hope Healthy Living.
Yes.
And our website, envisionhopehealthyliving.com.
Thank you, and thank you for watching, and we are going to see you in our next video. So can we say bye?
Bye.
Bye, and have fun learning at home. Great.
Finally.